Mode of identification can take a gel-based or liquid chromatography-based method through separation. The extraction of the protein is followed by this separation in one or two or multiple dimensions, leading to image analysis and finally through to identification using a mass spectrometer typically, whether it be gel or LC. Both will be available in the core facility we're building. The CE systems we're introducing, well, we'll introduce multiple vendors, but the one which I'm most familiar with, because I helped build, is this one here, which is built by Delta Dot, and it is a label-free analytical tool. You have anything going in will result in data coming out the back end without use of labels. We're using this technology in small molecules, genomic, proteomic, microbiology, and viral expression titer, as well as now QC/QA for vaccine development. This shows you one set of data. This is actually an E. coli cell lysate. What we've done is lay 9 runs on top of each other just to show that reproducibility is very good. Other CE systems haven't got quite the same ability to get the same result every time, but this is a very powerful tool. Notice also the extreme resolution on those peaks. That looks a bit like a mass spec trace. I also want to show you work we're doing with the FDA. I won't bore you with details of the algorithms, but suffice to say we have 2 ways of looking at analytes. The FDA sent us some heparin. Heparin is an anticoagulant, and unfortunately it's been contaminated by the vendor. I think it's probably pig intestines in the vendor source. And the problem is the contamination here, which is a hypersulfated chondrite, is extremely dangerous. The pure sample the FDA sent us, we were able to actually show to them and prove to them there was contamination. Where it came to the contaminated sample, the peak was really extremely obvious, and the reproducibility, again, was very good. This is not visible, but in here there are 2 peaks separated at the baseline using our technology. Some biomarker work. This was done by Judith Nagy. This is actually work done on diabetics, upregulated proteins. This was actually a mouse, fat-fed mouse, and you can see a 2-dimensional map with the proteins, various knockout conditions on the mice being used in this analysis. You can see the upregulated proteins very clearly in this analysis with annotated results out the back end. That's what it looks like blown up. The key, and I'll ask this question over lunch, the key is getting down into the deep proteome if you're looking for biomarker studies, and there's several ways you can approach that. First of all, you can get rid of all the, this is the dynamic range of proteins within tissue and within serum, and you can get rid of the very common proteins using chemical methodologies, which we've been looking at very closely, to get down into the deep proteome, which is where the interest is. Within our technology, you have the chemical concentration steps, but also you have a technique called stacking, which allows you to do a pre-concentration. And for example, in oligonucleotides, we've got a factor of 10 million improvement in sensitivity by using this stacking technique. This shows you sort of glycoform analysis. Top left-hand corner is mass spectrometry, and this is what the CE system looks like. And you can see that the difference between CE and mass spec is less than you might have thought. In fact, the quantification on these peaks is about 3%, whereas on the mass spec is about at least 10 or 15%. We're not just restricting ourselves to CE systems. We're looking at this mass spec approach, the MALDI. We have LC systems coming into the proteomics core. This is a particularly nice system. There is a mass spec called the Synapt, which I believe to be one of the best out there. It's made by a company called Waters. And the Synapt system allows the following sort of analyses to be done. You can see the high level of performance through those parameters. The applications which may be of interest in the Qatar frame is protein identification, characterization and quantification, conformation and ion mobility studies. We're also looking at metabolomics and even tissue imaging within the same system. This is a real workhorse capable of doing a wide range of different applications. So our planned proteomics projects are collaborations. We are focusing on diabetes and cancer. We're also interested in consanguinity. The same tool can be used to look at DNA, and we've been doing some work with the forensics people in the UK on short tandem repeats and various other ways of looking at identifying people. We're also working within the Human Proteomics Initiative through our scientific advisor, Dr. Nagy, who I think is director of it in the UK. We're interested in stem cell research. We're also looking for specialist programs. I've been talking to Dr. Khalid Muchacha of Weill Cornell about metallic content of proteins. We're looking forward to taking that collaboration forward. We're working with MD Anderson on breast cancer panel. We're very keen to work with bioprocess, and there is some talk about working with Texas A&M there, which we're going to try and pull down over the next few weeks. We are offering training courses. There's no point buying expensive bits of kit and have it lie around. So we are having training courses set up both in QSTP and at Imperial, something which we're very familiar with and have been doing for a number of years now, with various programs as part of the portfolio. We're future-proof in that the label-free paradigm has got applications going off into the future. They're all named after birds of prey. The peregrine is what you've seen so far, but we have a protein folding system called Osprey. We have microfluidic systems. My favorite, actually, is this one here, the Golden Eagle, which is the technology which is going to replace the 2D gels I showed you earlier. And we've just been negotiating with Wellcome Trust, which is the biggest medical foundation in the world, after Qatar Foundation, I suppose. The Wellcome Trust is going to be funding that, and they have agreed for us to do it largely in Qatar, if that's what's needed. This just shows you the DNA work. Using that Vertex technology, we get a sequence out the back end. This is single channel, no labels, and that shows you the cleanliness of how the DNA system works. This shows you short tandem repeat results for forensics and disaster genetics, and you can see very clear signals which would allow identification of people. Very quickly, the 2D gel electrophoresis technology which we're pushing on will have very high level of significance, I believe, for cancer biomarkers. If you've ever run a 2D gel, you'll know how painful it is. It can take 3 days. Reproducibility is very poor, and it effectively requires you to separate out a protein according to a pH and then separate out according to electrophoresis. It's very time-consuming, and the reproducibility is very poor. We have a microfluidic technology, which is now being funded by the Wellcome, and which requires a single-dimensional separation. Then using a little bit of physics, we can get two-dimensional information from that separation. Instead of taking 3 days, this will take 20 minutes, and we believe that the accuracies with which we can attain results is going to be about an order of magnitude better than you can with a gel. I'll skip that. It'll fit right into existing workflows. This is workflows for gel-based proteomics with two-dimensional separation, quantification, spot excision, and then a mass spec at the back end. You can go straight from mass spec through to a separation and identification. We see that the two-dimensionality of this microfluidic approach will allow you to get rid of some of these steps, each one of which produces errors. So again, minimum bias. Skip that. So our conclusions, we would like to establish this core in the QSTP. We're very eager to work with stakeholders, and any expressions of interest right now will be extremely helpful because we are in the process of refining our purchasing list. And so if there are collaborations which individuals want or institutions want, now is an extremely good time to approach us and make sure that we get what you need. We're having a high degree of complementarity in our tools. We have embedded informatics. We're taking that extremely seriously. And we're going to have the label-free minimum bias approach as part of the portfolio of technologies, but not exclusively. There is inherent compatibility with other CE, liquid chromatography, and mass spectrometer systems in there. We are definitely led by the questions which the Qatar Foundation, the Qatar people want answering. We're very proud to be part of that process.